Moving right along in the rebuilding the ICND1 lab structure. We left off the last nugget talking about IP address appropriate configuration and hard coding the speed in duplex. Now we're into basic OSPF. This is what we learned in ICND1 because right now all of the routers have IP addresses as well as the switches, but nobody can get anywhere. Ooh, I just thought of something that's not going to work right, which is the switches if we don't configure something else. I'm going to have to add that to the lab. But let's get into OSPF as it stands right now. It says configure basic OSPF between all routers. All networks will be in area 0. That's the backbone of OSPF. You should be able to ping or telnet to any device shown in the network diagram from any switch or router shown in the network diagram. This is what I'm going to have to adjust. I'm going to change the wording on that because right now, obviously, switches aren't going to run OSPF. So they need a default gateway. They're going to have to point somewhere. So we'll add that in. I'll do that, and then I'll add that to the lab. So let's begin. I'm going to start off on router 1 with the OSPF configuration. Now, I'm going to show a few ways to do this as we go. OSPF is going to exchange routes between router 1 and all these routers. Now note, I do not want OSPF to start trying to form relationships with an ISP. So we'll want to make sure that we prevent that or just don't enable OSPF for that network. I'm going to start off with show IP protocols, which shows what routing protocols are running on the router. Nothing, as expected. So I'll go into global configuration mode of router 1 and type in router OSPF and a process ID. Now this process ID can be anything that you want. It doesn't have to be the same between all the routers at all, but most of the time it's going to be, and I will tell you, in the real world, you always use one. Unless you just want to be creative or something, always use one. There's no reason not to. So now I'm going to go in and say, what networks do I want to enable OSPF on? So router 1, I'm going to start off with kind of the basic way of doing OSPF. Do a show IP interface brief. I see I've got one internal and one external network. I'm also going to hard code the router ID. I'm actually going to I'm going to make some of these requirements. So again, let me just put some reminders on here. So switch, default gateway, also OSPF router ID. You might remember from ICND1, the router ID is essentially the name of the OSPF router. By default, it will be the highest IP address on the router. So if I left everything as is, the router ID would be 188.23. Now, the problem with leaving that default algorithm is if you add interfaces in the future, the router ID could change and break stuff. So the best practice is to hard code. I'm going to make that a requirement of the lab. Hard code the router ID to 1. Well, not to 1.1. I'm going to put it as 1.1.1 because this is a router 1, but to hard code it as something. It doesn't have to be a real IP address, but it does have to be in IP address format. So you could even use 255.255.1 as the first and 2 as the second. It has to be unique. So I'm going to make router 1 1111 as the router ID. Now, that's its name. I'm going to enable OSPF by typing in network and then what networks I want to enable for OSPF. So I'll say 10.24.0.1. In this case, I'm going to be the most specific way I can with a wildcard mask. Remember, the wildcard mask is a matching mechanism, 0000. And before we talked about when I type in a network of 10.24.0.1, this is from ICND1, putting a wildcard mask of 0000 says enable OSPF on any interface that starts with 10, 24 as the second one, 0 as the third, and 1 as the fourth. Look exactly at that IP address on the interface and enable OSPF. Now you remember, the network command does two things. One, it says I'm going to advertise this network. Now remember, it's the network, not the IP address. The network assigned to that interface using OSPF. And I'm going to send hello packets. I'm going to try and form neighbor relationships out on that interface as well. But I'm not done here. I have to type in area 0. Which is going to be the area, the backbone that it forms in. So now, router 1 is running OSPF. If I go back here and do a show IP protocol, it's trying to form neighbor relationships on this network. Right now, it hasn't formed any neighbors. I'll do a show IP OSPF neighbor, and it's nothing. I've got nothing there. Now, we're going to dig really deep into the neighbor relationship later on in the series, but for now, we'll just say it forms neighbor. Okay, so now let's get our first neighbor running. I'm going to hop down to router 2. And enable that for OSPF. So let's come up here to my diagram, bring up router 2, and router 1. Let's get him out of the picture for now. Router 2. Let's go a little different route with router 2. I'm going to go into router 2. We'll do router OSPF 1. We'll do router ID 2222. just to get its name. And I'm going to be lazy. I'm going to say I want OSPF enabled everywhere on every 10 interface. So I'm going to type in network 10.0.0.0. So anything beginning with the number 10. If I'm going to do that, I have to have a wildcard mask of 0, which says look at the 10 on your interface. But I don't care what comes after that. 255.255.255. Space. So that says anything beginning with the number 10 because it lines up to the 0. But then looking at this, it says 0. But I don't care. I don't care. If I could highlight this, 255. I don't care about that. I don't care about this one. I don't care about this one. So that allows it to run on any interface beginning with the number 10, which in this case is going to be this guy right here and this guy, which is what I want OSPF running on. Okay, area 0, throw them in area 0. It should form its first neighbor relationship. I'm holding my breath. There it is. It didn't hold it for long. It moved from loading to full. We're actually going to discover what that means later on in the series. I'll do a show IP OSPF neighbor. Okay, we've got our first neighbor. We notice that this is a full neighbor relationship, and the other neighbor is a designated router. Again, more on that later. I think we talked about that in ICND1. That just means it is the one that is kind of the home base. All the other routers come to that one as kind of their central point of contact for that Ethernet network. Okay, so now I'm going to do a show IP route, but I'm expecting that not much is going to be, you can see router 2, I should say, is like, I haven't learned anything beyond what I had before. Why? Because router 1 is only running OSPF on this interface and only advertising this network, which router 2 already knows about. So yes, they formed a neighbor relationship, good for them, but router 1 isn't informing router 2 of anything new. Now, my question for you is if I come up to router 1 and do a show IP route, will I see anything being advertised from router 2 that router 1 didn't previously know about? Think about that one. The answer is actually yes. I'm going to come up to router 1. I see that it has formed a neighbor with 2222, show IP OSPF neighbor. There it is. It sees him as the backup designated router, BDR. So I'll do a show IP route, and I see my first OSPF route right here, 10.15.1.12. What is that? That is this WAN link right here because router 1, I lost my router here. There we go. Router 1 is not directly connected to that network at all. So it has now learned about that network from router 2. So it should be able to ping 10.15.1.13. Bam. It's now getting to this IP address, which it wouldn't have been able to ping before. Now, let me ask you this. Can it ping 10.223, or sorry, not 10.220, 10.15.1.14? Well, let's try it. Ping 10.15.1.14. Fail. We're failing. Now, okay, wait a sec. If it knows about this network, 10.15.1.12, if it knows how to get there, it knows how to get to router 2, it should be able to get to this just fine. Is that true? Yes, it is. Actually, it is absolutely true. If we were to open Wireshark and do a packet sniff on this line, we would actually see the packets coming from router 1, hitting router 2, going to router 3, and what would happen when they get to router 3? They drop. Why? Well, because it's coming from a source IP address of 10.24.0.1, and when it gets to router 3 looks at its routing table and says, do I know how to get to the 10.24.0 network? And it goes, I don't. Now you might say, logically, as you and I, as human beings look, it should be able to see the packets coming in on this interface and logically determine, I'll just send them right back out that interface, but routers aren't that smart. When it receives a packet, it's going to be like, okay, I'm looking at my routing table to try and find the way back, looks at its routing table, which right now, well, let's look. Let's hop over to router 3. Ching, bring this down. I have to activate my little always on top mechanism to keep it from going behind the scenes. So I go on router 3. Let's remove it up here and do a show IP route. It only knows about the 10.15 and 10.23. So when it sees packets coming from router 1 on the 10.24 network, it's like, I don't know how to get to you. So let's fix that. Let's go into global config mode. And I'm going to, thinking of more ideas for this lab, which will be fun. Passive interface. They just come to me as I go. Okay. Router OSPF 1. And I'm going to do network. Let's just do network. Let's do it the same way, right? Network 10.0.0.0.255.255.255 area 0, right? which now it will form a neighbor relationship. Ooh, I forgot to set the router ID. We'll do that. But it'll form a neighbor relationship with router 2. So router 2 should now be able to see this network, which it didn't previously know about. And let's just test it before we go any further. Let's come over to router 1 and hit the up arrow and try and ping router 3 again. Okay, so it failed right here, right? Previously failed. Hit the enter key. Bam, it's successful. Why? Because now I can come over here to router 3 and do a show IP route and see that it now knows about the 10.24 because it was educated by OSPF about this network. Now, so much to talk about. I'm like, oh, and then, what is this? Well, this is the administrative distance, the believability of OSPF. You might remember that from ICND1. So it is 110. You might remember that EIGRP has a believability or administrative distance of 90. RIP has a believability of 120. Static routes have a believability of 1. So the lower you are, the better you are. But what about this one? 65. That is the metric of OSPF. That is how good is this route. Now, OSPF metric formula, it's called the cost, is actually 100 divided by bandwidth in megabits per second. Okay, that's my quick little dirty formula to get there. Now, this is 100 megabits per second LAN. So the cost, essentially, of this network, for router 3 to get to router 1, the cost of this network would be 100 divided by 100, which equals 1. Right? So cost-wise, it's a 1. Now, what's this? Well, the default, let's take a look. So I'll do a show interface serial 0/0 on router 3. Now take a look. Router 3, and this is the default, believes the bandwidth to be 1544 kilobits per second. Okay, what is that in megabits per second? 1.544, which, does anyone know what kind of connection that is? Yes, you, sir? T1, you got it. That is a T1 line that router 3 believes this to be. Okay, so let's do a quick little calculator formula. If I could type calc right in Windows. I come in here and do 100 divided by 1.544 megabits per second. That's my cost formula, right? Now, OSPF does not round. It looks and it says that's a cost of 64. So it sees this line right here as a cost of 64 because it takes that formula 1.544, divides into 100, and so 64. Okay, so now add them up, right? So router 3, to reach this network right here, to reach this IP address, says, okay, I am looking at this, and it's a cost of 65. Oh, now that makes sense, because it's 64 for the T1 line. We just did that calculation. And it's 1 for the fast Ethernet connection. Man, I'm talking fast. Hopefully you're following along with me. But that is where that value comes from, and that is why router 3 is there. Now, I added to my little notepad file here passive interface. It's not a good practice to have router 3 trying to form a neighbor relationship over here. Why? Because who's sitting at that computer? Evil person X right here, trying to destroy your network. And if he sees OSPF hello messages, which are multicast, which he will see OSPF hello messages, he can actually open some simple tools. Matter of fact, Keith Barker at CBT Nuggets did a whole series on Backtrack, which is a freaky series. If you get in there, somebody can just boot their computer from a CD drive and have a malicious hacking tool that can form neighbor relationships with OSPF, destroy the network. It's not good. So with router 3, what I'm going to do is go into, actually I was right in the right mode. I'm going to go into router OSPF 1 and type in passive interface fast Ethernet 0/0. What does that do? What that does is it says I'm going to do one of two things. So the network command, remember, says I'm going to send hello messages out on those interfaces, and I'm going to advertise these networks. So router 3 will tell router 2 about the 10.15.1.12, and it will tell router 2 about the 10.23.1.0. So when I type in passive interface, it takes off one of the functions of the network command. It says I'm still going to advertise this network. I'm still going to let router 2 know about it, but I'm no longer going to send hello messages out on that interface, which prevents any neighbor relationships from forming over here, which keeps evil hacker X over here from peering with my device and really messing things up. Now, ICND1, we talked about OSPF authentication right now. We're not going to get into that, but that would be another way that you could protect it as well. Okay, so where are we at? Let's go back to our objective. Configure basic OSPF between all routers. Good. Area 0. Good. We should be able to ping or telnet to any device shown in the network diagram from any switch or router shown in the network diagram. Okay. So let's try it out. I'm going to go to router 3 and let's just ping router 1. Ping 10.24.0.1. Good. And just to make sure we can get there, 10.24.0.1, let's telnet over there. Good. Login and die, not conformed to the other logon banner. And this is our nugget love. Good. So I can actually telnet from router 3 to router 1. Let's exit out of there, and I'm back on router 3. Let's try out router 2. I'll ping 10.15.1.13. Oh, not 3. 13. Good. And I'll ping 10.24.0.2. Make sure I can ping the other. Oh, well, there I tested that accidentally. So I'm telnetting to this interface of router 2. I see the login banner, and we might as well log in. Nugget love. I'm there, sitting on router 2. So I can at least reach the routers. Now, something's broken. And that is the switches. This is what I was saying I have to add to the lab. Switch 1, switch 2, and switch 3. Let's try it. I'm sitting on router 3. I'm going to ping 10.24.0. Let's just go 11, right? Grab one of those guys. Fail. I'll just, for grins, let's try 12, which is switch 2. Fail. Now, why are these failing? Well, router 3 knows how to get to that network. Hang on, let me just erase these scribbles. Router 3 knows how to get to this network because it's in its routing table. And again, if we got the packet sniffer out, we would see it actually reaching switch 1 and switch 2. However, when it reaches those switches, they're getting packets, and they are like, I don't know how to get back to this network. Why? Because they aren't running OSPF. First of all, and they shouldn't because they're switches. But the bigger thing is they don't have default gateways. Okay, so in order to fix that, we actually have to turn these swouters into more of a switch than what they think. Because remember, in GNS3 we can't do switches with the iOS, so we actually emulate these by setting up routers with ether switch modules. So I'm going to come over here and I'm going to make this guy into a virtual switch. So I'm going to go to switch 1. I don't know how I'm going to do this on the lab objectives. We'll see how I type this up. So I'm going to go into switch 1. I'm going to type in no IP routing. Nope, not routing. Route, but no IP routing, which says you are not a router. You are essentially a dumb device. You do not do routing anymore. So let me go back here and do a show IP route. And notice it's like I've got nothing. Like even the routing table key, where it says O is OSPF, R is RIP, that you would see on a normal router. That's even missing because we turned off routing. All it's saying is default gateway is not set. So what we're going to have to do is make this thing just like a switch. Go in and type in IP default gateway. And say switch 1. Let's say switch 1 is going to use router 1 as its default gateway, right? So I'm going to go to switch 1, and I'll do IP default gateway 10.24.0.1, which says anything that you don't know about switch, go ahead and send it over to router 1. And now let's give it a whirl. Let's come over to router 3 and try pinging 10.24.0.11, which is switch 1, a second time. That's interesting. The first one I was like, okay, I'm good with that, but the second drop I was like, that's interesting. I'm really curious to do a Wireshark capture of why that second drop happened. Now we're going okay, here's my theory. So let's play a game of follow the packet, right? I'm going to go over here. We were sitting on router 3. The ping actually went, because of its routing table, over to switch 1, right? Switch 1 then said, I need to get to my default gateway where it comes up to router 1. So maybe right there it had to send an ARP to get to its default gateway. Router 1 looks at its routing table and says, oh, well, you actually need to go back through that way. Now, what he's going to do is he's going to send, he's like, okay, having a packet flow of this where it's like, choop, 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 choop. This little packet flow is not efficient. So what he's going to do is he's actually going to send an ICMP redirect. A redirect message to router 2. He's going to be like, you know what, sorry, not router 2. He's going to say, you know what, switch 1, it is not efficient for you to come to me to get back to router 3 because I'm going to send you down here to router 2 anyway. I don't want to be a middleman, so I'm going to send you an ICMP redirect message, switch 1, which tells you to get to the 10.15.1 network, or to get to this guy who's pinging you, just go straight to router 2. So that way we have a packet flow where let me just do this. We have a packet flow where the very first packet comes up to switch 1, hits router 1, and then router 1 redirects all future packets to where switch 1 just goes right back down to here. So that's my guess, is somewhere in this ICMP redirect world. Oh, where was it? Oh, Huh? Why am I not seeing that ping? I thought I had. Okay. Am I insane? Something. I thought, wasn't there. Okay, I'm just having a moment of weirdness here. Okay, I actually had to pause it and scroll line by line. Okay, I found it. So it's right here. This is where we this is before we added the default gateway. Then once we added, so this is my thought is this is the initial ARP request was the first failure, and then this was the ARP for the ICMP redirect as switch 1 went through router 2 to get there moving forward. But then as we move there after that, we get just solid pings the whole way. Okay, so what I'm going to do is I'm going to go to switch 2 and 3 and define their default gateways in the same way. And that is now done. So one more thing I want to do in this lab. So I want to now do this next piece. Configure a static default route on router 1 pointing to the ISP. Configure a static default route on router 2 pointing to router 1 and a static default route on router 3 pointing to router 2. Bonus bitcoins if you can find a way to do this using OSPF for router 2 and router 3 rather than the static default routes. And actually I want to find a way to test that too. So what I'm going to do, so let me first off talk through what that goal is. So I'm on router 1. I'm going to set a default route to go to the ISP so we can access whatever is out here on the internet. And by the way, the ISP is just a test device. I've got 2 IP addresses on there we can ping, 4.2.2.2 and 8.8.8.8 to tell us that we're successful with our communication there. And then it says, okay, go in and set up a static default route on router 2 pointing to router 1 and router 3 pointing to router 2. So we kind of make this little static route chain to get us there. But I'm actually going to go the bonus route. Because once you see configuring static route, there's no use in doing it a couple times. I want to do the bonus Bitcoin route to advertise this static default route using OSPF, right? So first off, let's go up to router 1. Do I already have a session there? I do. Okay, good. So router 1, I'm going to do a show IP route right now, and all I should see is those OSPF routes that it's learned from its neighbor. I'm going to go into global config mode, notice gateway of last resort not set, and I'm going to do a IP route as our static route. Everything, so this is the all for IP address and subnet mask, to 188.23.163.174, which is this guy right here, the ISP. Good. So first off, let's just go back and do a show IP route verification. Now I do see the default gateway is set, and I see that static route. Again, remember the administrative distance of 1, metric or cost of 0, because it's static. There is no metric for a static route. So I'm just going to make sure I can ping 4.2.2.2. Which is good. That looks good. And 8.8.8.8. And by the way, I've just configured those as loopback interfaces on the ISP router so we can simulate as if we really did have internet access. But those are the, if you're trying this on your own, those are the only 2 that will work because it's not the real internet. Now, I want to use OSPF because I want to now prove to myself. I'm going to go to router 2. Where is router 2? I don't have it open. Router 2 right there. And do a show IP route on there. Now, one way that I could do this is I could put the same static route pointing it to router 1. But I'm going to use the bonus Bitcoin route. I'm going to go into router 1, global config mode, and I will do router OSPF 1 and show you one amazing command. I'm almost positive we talked about this in ICND1. If not, we should have. So I know we should have. So it is default information originate. That's the command. So there is actually 2 flavors of this command that I want to talk about. Default information originate tells router, if I just hit the enter key, done, right? That tells router 1 to now say, okay, if you have a default route, router 1, advertise that to all your OSPF neighbors, and they'll advertise it to their neighbors and their neighbors and so on. So now, after typing that command on router 1, I should be able to go to router 2 and just hit the up arrow. And now see, look at that. We've got a default gateway is now set where it wasn't before we did that command. Default gateway is now set, and it's showing as an external type 2 route. Now, we'll actually get, we'll see it, but we won't get too deep into it. External type 1, type 2 route in this series. That's more CCNP stuff. But nonetheless, we now have a default route pointing to router 1, and I can even go over to router 3. Right here. And I didn't do anything over here, but it will just propagate that default route on and on and on. It sees the same default route pointing to router 2 as its path to get there. Now, the other flavor of this route, so default information originate, what that tells router 1 is say, okay, router 1, if you have a default route, which it does, right? Because we defined it. I'll do include IP route. We defined that default route right here on router 1. So it says if you have a default route, go ahead and send it to your friends. There is another command we can type in, default information originate, and I'll hit the up arrow and do always. And what that does is tell router 1, I mean, the function will be the same. It's not like anything special is now going to happen. Is it says, okay, router 1, even if you don't have a default route. So even if we didn't put that default into the ISP, still advertise, make up, like pretend you do. When you talk to router 2 and your neighbors, pretend like you have a default route and send it on. So default information originate always is useful if maybe this guy has most of the routes going to the internet. Maybe it's running BGP, which gives it the internet routing table, but it doesn't actually have a default route. You can say still advertise the default route to everybody else. Okay, so that now allows everybody to have a default route to the internet. But it's not going to work. I know, because so you're going to be like, okay, so we can go to router 1, right, and ping 4.2.2.2. Right, good. But I go to router 2. Let's go right here, router 2, and if I do the same thing, ping, even though it has a default route, right, so it's saying I can get out, ping 4.2.2.2, fail. What? Okay, why is this one failing? Well, same thing as before. Let's go in here. Router 2 is like, woohoo, I'm going to the internet. I know how to get there. Goes right through router 1 and bam, hits the ISP. Problem. ISP actually has a router right here receiving you. First off, you just came right across and ISP is seeing you as 10.24.0.2 as a source address because you're coming from router 2. That's a private address. That is not good at all because we just allowed a private address to roam right through to the ISP. And ISPs, they actually have an access list, everyone should, that has an access list that denies any RFC 1918 address. It's the only RFC number I can rattle off the top of my head. 10. Whatever, 172.16 through 31, and 192.168, they will actually deny dead all of those IP addresses from getting to the internet because they're private. So what do we have to do? We have to configure this guy for NAT, Network Address Translation. That will be one of the next exercises we do in the lab, but that will affect both router 2 and router 3 because they'll be coming out as a private address, and that will not fly from the ISP level. That's coming up. For now, we've configured OSPF. We've got default route running. I hope this has been informative for you, and I'd like to thank you for viewing.